afternoon, everybody. Thanks for joining us today for winter precipitation. It's kind of an ominous thought. Some of you have experienced, maybe some already, and we're kind of trying to today up here in the northern part of the state. My friend and our extension weather guy, Dwayne Friend, is with us today to deliver this webinar. Today's webinar is part of our Everyday Environment series, which is offered on the second Thursday of each month. My name is Peggy Doty, and I'll be attempting to moderate for Dwayne today. The webinar will be recorded, and the recording will be shared to the University of Illinois Extension's YouTube page. Sometimes that takes a while. I will grab the link here in a little bit or near the end and get that put in for you in case you would like to wait for it. But usually we send out an email, I believe, so that you know it's been put up, so you don't have to constantly check that. So please allow some time for processing. We'll follow up, I'm sure, with an email to let you know it's there. If you have any questions at any time, we will go straight through the program, but I will keep an eye on the chat, and we will keep an eye on those questions. Just stick any questions or thoughts in the chat. If you could keep that for Dwayne, that would, Dwayne specifically, that would be great. And finally, we want to mention that this webinar is a certified green event through the Institute for Sustainability, Energy, and Environment at the University of Illinois. We recognize the importance of sustainability, and this webinar format has made it possible for us to offer these programs with a lower carbon footprint than our traditional programs, and we encourage you to think about ways that you can also be more sustainable in your everyday life. So we are going to, we got the recording on, we're good to go. So Dwayne, it's all you.
All right, thank you, Peggy, and welcome everyone on this balmy winter day. I think we're going to have to change our definition of what winter weather is. Actually, we're going to be talking about that a little bit later on today. So we are going to go ahead and start up. Like I had mentioned before, we had quite a few that registered, but I think a lot of folks are waiting and we'll watch the recording when it comes along. We've got about a little over 60 people on, I guess. But as Peggy said, if you've got questions at any time, just put them in the chat box. We should have plenty of time at the end of the presentation to address those. So today, what we're going to talk about are several things. We're going to talk about typical winter weather, or what has been typical winter weather in the past. We're going to talk about snow, sleet, freezing rain, how they form, why they're different from each other. We're also going to talk about a few extreme events that have occurred throughout history in the last anywhere from 20 to 100 years ago in parts of Illinois and other parts of the United States. We'll describe a little bit about blizzards, what really constitutes a blizzard. We'll also show some extreme events for that as well. Something else we're going to talk about, which not all of us here in Illinois are affected by, but if you're up around the Chicago area, or I know we do have a few folks that are coming in from other states. If you're up around the Great Lakes, we will talk a little bit about lake effect snow and lake enhanced snow. There are actually two different ways that extra snow can be formed. So we'll talk about the difference between those two. Another phenomena that occurs occasionally, and probably a lot of you have experienced this, is something called thunder snow, where you actually have that crackling of thunder during a snow event. We'll also talk about different types of winter weather systems, where they originate from, and what kind of weather they usually are associated with. And then we're going to end up talking about what weather trends have been in terms of winter weather over the last 100 years or so, what's predicted for the future, and what kind of considerations we may need to think about for those future trends. So let's get into talking a little bit about snow. Everybody in Illinois has had or experienced snow at some point. Start off with a little bit of trivia. I know trivia events are not quite as popular as they used to be a few years ago, but here's a little bit of trivia for you. Any precipitation during any time of the year here in Illinois, here in the Midwest, essentially anywhere outside of the tropics, started out as snow. Even when we get that heavy rain in the middle of summer, it started out as snow. Has to go through about 1,000 feet of air that's above freezing to melt and become rain. And you may have noticed sometimes, especially in maybe the early spring, sometimes early fall, we get that really cold rain. And sometimes it's because of the cold air, but then the even colder air above it that allowed that snow to get fairly close to the ground before it melted. All snow is ice crystals, but they're different than ice pellets. They're different than hail because they don't go through a liquid phase. They go directly from water vapor, which is the gas form of water, to crystals, to that solid phase. They don't go through the liquid phase. Here's another bit of trivia for you. Snowflakes can actually be considered minerals because the definition of a mineral is it has to be solid, has to be naturally occurring, crystalline in shape, and non-organic. Perfect definition of a snowflake. So how do snowflakes form? Well, up in the clouds, again, where it's really, really cold, you have at the microscopic level, the beginning of a snowflake, where water molecules will glom onto some other type of particle. And they have to do that. They can't just start forming crystals out of nothing. They have to actually attach to another particle, whether it's a little piece of pollen, whether it's a piece of dust, whether it's a smoke particle. Again, this starts out at the microscopic level, but you have these water molecules that go from being the gas form of water directly to those ice crystals. From that point, the game really begins, because to get that to form larger in terms of its surface area and get heavy enough to fall, it has to get much bigger. So one of the ways it does that is within that cloud, and we said that those clouds are going to be really cold, they're going to be below freezing, but we can still have liquid water in that cloud next to snowflakes that are forming. This is called supercooled water. And this is very common in clouds. What happens, and I'm not going to go through all the physics or thermodynamic events or anything with it, but essentially what happens is those ice crystals grow at the expense of those water droplets. Those water droplets continue to evaporate water into that water vapor. Those water molecules are then attracted to that snowflake, and then it forms more ice crystals on it and can continue to get bigger. It starts out as these little faucets, and then you can have branches that form out. You can have more faucets form, and essentially anything can happen. It can switch back and forth between forming branches and facets. It can happen at the same time. And what's really cool about this is even the slightest difference in temperature, the slightest difference in moisture can change what that snowflake ends up becoming. So you have probably heard that terminology that says no two snowflakes are ever alike. The possibilities of what a snowflake can become are infinite. Now, at the same time, I've got to think over the millions and millions and millions of years that we've had snowflakes on Earth, and the trillions and trillions of snowflakes that have occurred. There's got to be at least a few of them that have been alike. But again, the possibilities of what that snowflake becomes is really infinite. And when you look at the shape of snowflakes, they are really cool. There's, again, just amazing different ways that those snowflakes can form. And you can see just a couple of examples here. Very pretty shapes to them. And we don't really get to appreciate that very often when it's hitting in the face or we're shoveling it. But it's really an amazing piece of nature. Now, all of this, again, is related to what the temperature is at the time that they're being formed, how much water vapor is in the air, and all of these other things that are taking place. So all of that makes up one snowflake, but there are millions of individual crystals in there. There's actually a number of different basic classifications of snowflakes. And as it says here, this physicist, Yukishiro Nakaya, set up a classification with 41 individual types. And you can see they range from looking like the individual star shape or crystalline shape that we think of a lot of times to more like needles, sometimes just clumps. So there's just an amazing array of different basic shapes even out there. The other bit of trivia that I want to give you for snow, and I hear this a lot of folks will say, well, it's too cold to snow. That's not true. It is never too cold to snow. And one way to think about this, if you go to the North Pole or South Pole, where it is typically in the wintertime 50, 60, 70, 80 degrees below zero, they still get snow. It's just that it's not going to be very large, but it can still happen. And in fact, the potential for snowfall at the poles is there because when the air is so cold, it's going to have a high relative humidity because very cold air, while it can't hold much water vapor to begin with. So whatever water vapor is there is going to be close to its maximum that it can hold, which means if it's close to 100% relative humidity, the chance for precipitation is present. Just mentioning a few things for Illinois. Now, this is the state average. Not everybody in the state would have had this much, maybe in some areas more. And some of you may not be old enough to know these first two. I remember these dates very well, 78, 79, and actually even 77. 3 very cold winters in a row. And you can see with this, for the state average, 78 and 79, almost tied in terms of the state average for being the snowiest year, over 44 inches of snow. You have to go back to 1912 for the next one. The one after that, not that long ago, 2014 with 39.4 inches, and then 1960. So the top 5, well over 3 feet of snow. And this one, I've got the thing right in front of, or the box in front of my title, so I can't see what year it is. I think that's 67. But it was, or no, this was 79. I'm sorry. Yeah, this is 79. And any of you that are from the Chicago area and were in that event or that year, you know that it was not fun to get around. And in fact, it was so long in getting things back to normal in terms of traffic flow and the L and where it needed to go that the mayor at the time got kicked out because of it. Now for this one, it takes you a minute to kind of realize what's going on, but you see the person standing there, look off to the right. At that lower level is the garage. So that person is essentially standing on their roof. And that was out in the Ohio Valley and Great Lakes in 1978. There's huge amounts of snow that occurred during that year. And then Snowmageddon, another thing that occurred in the Chicago area, 2011. See all the cars stranded there. So now let's talk a little bit about sleet and freezing rain and what the difference is between the two. We know what rain is. That's just a liquid form of water. We usually get that in the spring, summer, and fall. But then we have freezing rain and sleet. Neither one is the same as snow. The reason is because both freezing rain and sleet go through a liquid phase. With sleet, what's happening is it starts out as snow, but then it goes through a very shallow layer of warm air, enough to melt that snow into rain. But then below that warm air, it gets into another layer of very cold air, cold enough to refreeze that rain before it hits the ground. And so instead of getting snowflakes, you get ice pellets, which is called sleet. If you've ever noticed when a sleet episode comes along, typically it doesn't last too long because usually when this is happening, it's a transfer or transition that's going on between a lot of times maybe rain to sleet to snow, which is associated with a frontal passage coming through, a cold front coming through. Typically, sleet events, fairly short-lived. Most of them maybe 20, 30 minutes at most. Freezing rain event, sometimes those can last much, much longer. Sometimes those can last for days. What's happening there is that warm air layer above the ground is much thicker. And so again, it starts out as snow, changes to rain, but then when it gets to that cold layer that's at ground level, that cold layer is not thick enough to allow that rain to freeze before it hits the ground. But then once it hits the ground, it freezes on anything that's there. And so that's the difference. And again, these freezing rain events can be very long-lived. Some of the conditions that set up for freezing rain. We have our typical low pressure system on the left where we've got the warm front in the red, we've got the cold front in the blue. There's two areas where that can happen. You can see for number one, it's out ahead of the warm front where you've got that warm air out maybe several thousand feet above ground, but at ground level, you're in cold air. So that's an area where that event can occur. Also, right behind a cold front. Now with that one typically, as that cold front is moving through, it's usually moving through pretty rapidly. So if you get a freezing rain event behind a cold front, typically it's not very long lasting. The one that can be a long lasting event is when you have a stationary front like that middle illustration is showing. If that stationary front stays in place for hours or days, you can continually get that freezing rain on the north side of that. And then again, when you get a really cold Arctic front coming through, you may get some freezing rain with that. But again, typically that's not going to be very long-lived. This is an illustration way back in 1883 in the town of Lincoln. Here it's calling it the Great Sleet. And yeah, there may have been some sleet, but you can see where most of the damage is being caused is from the freezing rain that probably came afterwards. So how much freezing rain do we get here in Illinois? We can see the central part of the state is kind of the bullseye. We can get upwards of 5 days a year with freezing rain in the central part of the state. To the south, a little bit less, maybe only 3 or 4. To the north, maybe only about 4. Now, why is it the bullseye in the center? Well, a lot of times when you look where that polar jet stream is, sometimes in the wintertime, its average position is almost midway across the state. So you get a lot of these low pressure systems riding along that polar jet, and that can bring the potential for freezing rain. If you also look at the number of hours of duration for freezing rain events, you can see central Illinois again is in that 9 to 15 hour range for freezing rain events. And that is a very long period of time, can cause a lot of damage when you have freezing rain events that occur that long. You can see out on the west, they have very little, except up in the northwestern part of the state. Northeastern part of the United States, they can get hit even worse, especially New York State can have very long-lasting freezing rain events. And those of you that also experienced the winters of 77, 78, and 79 probably remember that Easter weekend storm of 1978. Very early Easter that year, it was in March, and it started on, I believe, a Friday evening and kind of lasted through Sunday. Wide area of Illinois and some adjoining states got hit with freezing rain. Some areas were without power for 2 weeks because it was such a wide-ranging damage event. Here's just another example. This one is from Bloomington area, I believe. Just huge amounts of damage. And if anybody remembers that, on the Monday after Easter, it was up in 50-degree range. So I guess at least people had better weather to clean things up afterwards. A lot depends in terms of damage on how thick that ice is. If it's less than 1/4 of an inch, it's kind of a nuisance because you get get it on your windshields. It's hard to take off. The bridges are obviously going to be slick. You get ice on the trees, and you might have to watch out for falling twigs. If it gets a little bit thicker, between 1/4 and 1/2 inch, you start seeing tree limbs breaking, especially birch trees. Those are some of the first to go, at least in my yard. And the roads become very hazardous. Salt may not be able to take care of that. You also start having power outages, especially if there's some wind involved. And then the really major damage with this is that ice gets over 1/2 inch thick. Usually have widespread damage then. Many power lines down, many limbs down, and the roads are pretty much impassable. Right from there, let's move on and talk a little bit about blizzards. What technically makes a blizzard a blizzard? I'm not talking about the Dairy Queen kind. A blizzard is when you have wind gusts of 35 miles per hour or greater. You have less than 1/4 mile visibility for at least 3 hours or more. Now, you can have a blizzard without falling snow. If you already have snow in place and you have those first two conditions, you can have what's known as a ground blizzard. Some historically significant blizzards. This one occurred out on the East Coast. This is actually from New York City. Shut down New York City for several days. And if you think about what the technology was like back then, people couldn't, maybe had phones, but even the phone lines would have been down. They wouldn't have had radio at that point or anything. So that would have been a major economic impact to that city back at that time. One a little bit closer to home, and some folks may remember this, back in 1993, mid-March, we had what was called the storm of the century. Huge amounts of snow, almost 3 feet of snow in some cases, just from that one event. And that was caused by something that commonly occurs along the East Coast in the wintertime, a low pressure system called a nor'easter that kind of rides along that eastern coastline, brings in moisture from the Atlantic, and then puts it down as snowfall. And this is the one that I was mentioning earlier, the blizzard in Chicago of 1967. You can see how bad it was in that year as well. Now, also something for folks in the Chicago area, in the suburbs, and if you live in other areas near the Great Lakes, you may be affected by lake effect snow. This is a localized area close to the lake where you can get very heavy amounts of snow. Typically, what causes this? There are several things that can cause lake effect snow. As that air moves across the lake, it's moving across relatively warmer water. Water is much slower to cool down than land does. So it is always warmer typically in the wintertime than what the air above it is. So that air picks up that moisture. And then once it gets to the coastline again, starts being pushed up on the higher elevation of that land. It's kind of the same concept as when air gets forced up a mountain. As that air rises, it has the opportunity to cool and start forming precipitation. The other thing that happens is something called frictional convergence. As that air is moving across that relatively smooth water on the surface, it can move along at a pretty good speed. Once it gets to the coastline, that ground has more friction as that air moves across it. And so that air starts slowing down while the air behind it is still trying to move along at its original speed. And so what happens is it pushes that air up, and that can also cause additional rising of air and the potential for additional precipitation. One of the things that if you're in this area may also notice, this is a satellite view, you can see these big long bands of, or they're called snow bands. So it's not just widespread precipitation. Sometimes they're in these relatively narrow but rather long bands where you're getting very heavy snow. In between these bands, you have next to nothing. So what's happening there? Well, it's almost like those outer bands that you see on a hurricane. In where those bands are at, you've got air that's moving upwards very rapidly. Again, when that air is rising, it can cool, form clouds, and create precipitation. As that air rises up, it gets up to a certain point, starts spreading out. And in between these bands, that air gets forced together, which makes it denser. And so in between those bands, the air moves downward. And when the air is moving downward, you're not going to have clouds, you're not going to have precipitation. So where the bands are at, you get very heavy precipitation. In between, next to nothing. Some things that can affect how much snowfall occurs. One is how long that air travels across the water. If that air is traveling in an orientation that's going to leave it across that water for a long period of time, it has more opportunity to pick up moisture. And so then it also has the opportunity to create more snowfall. The other thing that occurs, which I've kind of talked about before, is land barriers. So we're not talking about huge mountains or anything, but even a relatively small elevation change pushes that air up. And the more that elevation change is present, the more opportunity there is for air to rise and for precipitation to occur. The other big thing that can affect how much snow, if any, occurs is ice cover. Once you get ice cover on the water, it shuts down that transfer of moisture from the water to the air. The thing that's occurring, though, is over the last few decades, our lakes have stayed warmer, stayed above freezing. We have much less ice cover than there used to be, which means the potential for that lake effect snow is lasting longer and longer into the winter season. The other type of snow is lake enhanced snow. This occurs when you have one of those low pressure systems already moving over the area, can have a widespread snowfall event, but then because of the counterclockwise motion of that low pressure, that air can move across the water on the lakes. And then again, just like before, it can actually increase the amount of snowfall that's already occurring in that low pressure system, but it's just going to happen in localized areas. So here it's showing kind of an example. You can see the light blue is where the overall precipitation is occurring. You can see where the low is at down there on the bottom. And again, low pressure systems in the northern hemisphere, the air circulates around it in a counterclockwise motion. So as that air moves counterclockwise around that, as it moves off the water onto the land, you can get localized area where you have that enhanced effect from that circulation. Another thing we can talk about, and I don't know how many of you experienced this, I have on a few occasions, and if you have watched the Weather Channel at all, you know this person. He is been on the Weather Channel for years and years. Right now I'm having a brain malfunction and I'm not thinking of his name. But anyway, he gets really excited when he is out on location and having talk with the camera and the folks out listening, and then thunder snow occurs. And he just goes crazy over this. So what causes thunder snow? When do you usually experience thunder snow? Maybe those of you that have experienced before notice that it happens under certain conditions. It's usually not when the air is really cold, typically when it's right around freezing or maybe just a few degrees above, and we're having really heavy, large snowflakes occur. Under those conditions, in some cases, you have a little bit stronger uplift in those clouds and in localized areas. Much like with a thunderstorm, not nearly as tall as what a thunderstorm would be, but if you were flying up above the clouds, you would see these areas where some of the clouds were much taller. In those areas, you've got a lot more unstable air, you've got a lot more turbulence taking place, and with that turbulence, you can have differences in voltage occur, which then can create lightning. And then you have the thunder snow that occurs. One thing to know about thunder snow is, unlike regular thunder from a regular thunderstorm that you can hear miles away, thunderstorm, you have to typically be very close to where that lightning is occurring, because that snowfall kind of deadens the sound of it. You got to be within a couple of miles of that lightning, which really, if that you're thinking about it, if you've got lightning that is occurring only a couple of miles away, hopefully you're going inside very quickly. Okay, another area we're going to talk about are winter air masses. These are where a lot of these storms originate from, or where this cold air originates from. And one of the first ones I want to talk about is the dreaded polar vortex. The media has made it sound like this is some new thing that's occurred here in the last few years. It's not. It has been around forever. It's just that that term polar vortex has been media-sized, and it is used very commonly today, but it has been around forever. Essentially, what the polar vortex is just this enclosed loop of winds near the North Pole that typically stays near the North Pole, and it keeps all that really, really cold air locked up there. Sometimes, though, what happens is that very strong enclosed loop of air weakens. What that allows are these pockets of this really cold air from near the poles to move farther south. That's essentially what happened last February for us. We had that, and then the thing was that it got blocked, and so it just sat over the Midwest for about 10 days. And here's what the temperatures look like during that period for February 15th to 22nd of this year. You can see near the North Pole, they were 20 to 30 degrees above normal. Same way with central Canada. But here in the Midwest and the Great Plains, we were 25, 30, sometimes 40 degrees below normal. And you can see the coldest area there, or not the coldest, but the greatest temperature below average was there in Texas, where they also suffered greatly from having natural gas shortages. Now, can that happen again? Unfortunately, as you can read through this, what research is showing is that what they've been seeing over the last few decades is that there's more episodes of this polar vortex getting to the point where it weakens and gets a lot wavier, which allows these outbreaks to occur. So if, with that being the case, yeah, there may be more outbreaks of this chilly air, really, really cold air that occurs. Another place where winter storms originate from is up in the province of Alberta, Canada. This is something that we sometimes get in winter. More often, it's in maybe February, maybe even March. It's called an Alberta Clipper. It's a low pressure system, very fast moving, typically moves from Alberta down to the southeast. And even though it is moving very quickly, it also has very heavy snowfall associated with it. And so you may only have snowfall that'll last for 3 or 4 hours, but you may get 4 or 5 inches of snow out of it. And then behind it, typically you have very cold air. Another storm that can affect us here in Illinois is something called the Colorado low. If you ever watch the weather forecast and you notice a low pressure system out in the Four Corners area of the United States forming, that typically is going to run right over Illinois eventually. If it happens in the wintertime, anything to the north of that low is going to be snowfall. So depending on where that low ends up, whether it's in the southern part of the state, the northern part of the state, it's going to make a big difference in how much snow different parts of Illinois get. Something else that you may hear about occasionally is called Pacific air. This is actually air that originated from the northeastern Pacific Ocean. Has a little bit longer distance to reach us here in Illinois. It's a cold or cool, moist air mass, has to move across the Rockies and then move into Illinois. But that does happen from time to time. Now, depending on what kind of air it's replacing, it may bring colder air, it may bring warmer air. Typically in the early winter, for example, if we got a Pacific air mass coming through right now with today's weather, it would bring us much cooler air. On the other hand, if it happens in the dead of winter, when maybe we've got really cold air in there, this Pacific air may actually warm us up 10 or 20 degrees. A little bit on weather terminology. I think a lot of people are already aware of this, but just to go through it again, a watch just means things look like a weather storm is going to be approaching. Be prepared for it. An advisory is when winter weather is probably going to occur and occur very quick or very shortly, but things might not be really, really bad. A warning, on the other hand, means you're going to have really extreme winter weather occurring, either severe cold, ice event, heavy snow event. I won't spend a lot of time on this, but I do want to mention that just like any type of disaster out there, for example, we get a snow event, heavy snow event, we get a heavy ice event, especially if it's widespread, we can be basically shut down and stuck in our homes for several days or more. So it's good, just like with any other type of preparedness, to be prepared for that type of winter weather. So some of the things that you need to think about, and the CDC has added this to the winter preparedness kit, is things to be prepared for, such as having those disinfecting wipes, having those face coverings. Some other things to think about: having your prescription medications, plenty of that on hand, having non-prescription medications, having your eyeglasses and contact lens solution available. If you've got small children, having that formula, plenty of that available, plenty of diapers, wipes. If you got pets, make sure you got plenty of pet food in hand, cash. A lot of times we don't think about that, but if you can't use a card, can't use a check, cash may be your only alternative. Make sure you have, if not the originals, copies of important family documents, something warm for each person to have, a blanket or a sleeping bag, plenty of clothing, fire extinguisher. And I won't go through all of these again, just basic preparedness for this. And I think a lot of folks now, after the last 2 years, a lot more familiar with what's needed under those circumstances. In terms of winter weather driving, now we may have some folks from a more southern state, and we sometimes think we know how to drive in winter weather, but how many times do you see vehicles off the road, especially for the first snow or two? You really have to think about, especially with that first snow, how you have to change your driving. You cannot drive as fast as you want, even if you've got an all-wheel drive or a four-wheel drive. You may be able to think you're driving at a good speed, but you're not going to be able to stop the same way you would stop without that snow or ice. So the other thing to be sure of is make sure your car is ready for winter weather. Make sure your battery's in good shape. Make sure your wipers are in good shape. For coolant, coolant needs to be changed in a vehicle every few years. It just doesn't last forever. Make sure your tires are in good shape. You got plenty of tread on them. All right, so let's move on to what we can expect for this year. Here's the latest forecast for our season. As you can see, from December through February, it's a really good chance we're going to average above normal in temperature. The farther south you go, the better those chances become. For precipitation, it also looks like we're going to be above normal for the winter. Right, let's get a little bit closer to Christmas. For the next 2 weeks, we have got a really high chance of above normal temperatures. So if you're hoping for snow before Christmas, I'm afraid you may not get it. Same way with precipitation. Probably if we get that, it's going to be more in a rain event. And I'll say that, and then if we get a large snowfall 2 days before Christmas, well, you know my email. Here's the extended outlook. And this was made back a few days ago, but this is for December 18th through the 31st. So this would include Christmas. Southern Illinois, a 70% chance of above average temperature. For the rest of the state, between a 60 and 70% chance of above average temperature through the end of December. For precipitation, we have about a 50% chance, 50 to 55% chance of above normal precipitation. So it looks like we're starting the winter with a warm and wet December. So how does this compare to what we've had in the past? If we look at the really long-term trends, this goes from 1895 to 2017, so well over 100 years. This is looking at winter maximum temperature. You can see throughout the entire Midwest, or the north central part of the Midwest, maximum temperatures for winter have increased, especially up in the northern tier of states, Minnesota, Wisconsin, and Michigan. Minimum temperatures have increased even more throughout that entire area. So this isn't something that's happened recently. It's been happening over the last over 100 years. Now you may be thinking, well, that's great. I don't have to spend as much on heating now. And in fact, 12 of the last 20 years have been some of the lowest in terms of heating degree days. How much it takes to heat a particular area. So in that regard, yes, the trend for warmer weather for winter is decreasing our chances of having to spend a lot to heat during that time. And what are the projections for the future? Well, by the time we get to about 2050, what we're going to see, and this trend is going to continue, is we're probably going to have our average winters be warmer than our warmest winters are right now. So what does all that mean? If we're going to have much warmer winters, what are some of the things we have to think about? Well, first of all, probably a lot more rain events. Unfortunately, as we transition, before we get to all rain events, we may have more opportunities, unfortunately, of more freezing rain, especially in the central and northern part of the state. In terms of looking at soil conditions, if we have warmer winters, if those soil temperatures end up getting close to or above, especially above 50 degrees Fahrenheit, and stay there for any length of time during the winter, you're going to have more organic matter decomposition taking place. Also, if you've got that soil out there and we're getting more rain events, potentially heavier rain events, we've got more potential for soil erosion. For nitrogen application in the fall, if those soils stay warmer, could mean more nitrogen loss for that fall application. Around the lakes, when you may have heavier lake effect snowfall, especially as the lakes have less and less ice cover. On the other hand, just because we're going to average warmer weather overall does not mean we won't have these periods where we get these Arctic blasts. Remember what I said about that polar vortex. So even though the overall average may be warmer, we still may have short periods where we get extreme cold. So we still have to be prepared for that in terms of our clothing and our winter preparations. So with that, hopefully I covered some of the things that you wanted to hear about. And at this point, I've got up here the survey. If you'd like to scan that code or type in that URL, you can do that at your leisure. You can see the registration URL for the next Everyday Environment webinar. That's going to be a discussion of the International Panel on Climate Change report with Abigail Garofalo as a presenter. So with that, Peggy, I will open it up for questions.
Yeah, thanks, Dwayne. Again, while we're here and conversing here at the end, you can again use that QR code with your phone and go straight to the link, or cut and paste, and or potentially click on that. I'm not sure, but please do take a few minutes and do the surveys. It helps us kind of gauge where we're going with future programming and what your interests are. Yeah, this is so relevant. It's the perfect time. I'm so glad you did this. And I always learn a lot. I'm sitting here writing notes, and I'm supposed to be paying attention to the chat. So luckily we didn't have a ton of questions because I'm doing my student thing. Initially, one person had asked if all snowflakes had 6 sides, but then right away you put up that perfect example of the 41 different potential base shapes. So I think that was an immediate answer to that question.
And yeah, now within a snowflake, it'll have those 6-sided crystals, but they're so small in some cases, the overall shape won't appear to be that 6-sided shape.
See, there it is again, more good information. So there are those 6 crystalline, what would you call them, facets, but they're not all layered in a 6-legged.
Right.
Okay, cool. Excellent. I'm looking here. Yes. So one of the things that came up, Lisa, one of the Janes and Susan Chenoweth get the points for Jim Cantor being the.
Oh, there we go. Yeah, that Jim Cantor. Yeah,
I had prizes, but they all 3 were like, "Is it? Is it?" I looked up his face. I didn't know.
Yep. Yeah. For some reason it just totally escaped me.
One of the questions that Jane B asked is, are the summer, I'm assuming, weather patterns much different than the winter patterns?
That's a good question. What has been seen in the trends is the greatest change in seasonality is occurring in wintertime. Spring, summer, especially summer. Summer has gotten a little bit warmer, but not nearly to the extent that our winters have gotten warmer. So it's not an overall yearly warm up. It's actually happening more seasonally. Our winters have gotten much warmer than our other 3 seasons have. Good question.
Interesting. Got lots of good kudos. I will put the link to the YouTube in a moment here again. It is in the chat early on. I'm scrolling there. Lots of, is the Arctic Clipper the same as the Siberian Express?
Well, with it being an Arctic Clipper, and I'm not quite as familiar with that, I would say no. That is more of a kind of like a polar vortex outbreak where you get that extreme cold air from near the poles or maybe even northern Siberia. Sometimes it actually comes across the Arctic Ocean into North America. And that's going to be, in some cases, one of the best examples I can think of from that was back in, I believe, 1983, the day before Christmas. We had an extremely cold air mass come in, 40-mile-an-hour winds. I can remember I woke up the day before Christmas. The outdoor air temperature was minus 25, and the wind was blowing at about 40 miles an hour. And the wind chill was about minus 65. Got up to a balmy -4 that day, I remember. But that would be an example of an Arctic Clipper. It's usually more associated, I believe, with a polar vortex outbreak.
Excellent. Someone asked if you could put the code. I can't cut and paste your evaluation link. Can you by chance drop that in the chat, Blaine?
Let me see if I can do that.
I'm not able to cut and paste it.
Oops. Well, let me do this. Let me see if I can.
First slide, maybe. I didn't catch it.
See if I end the show and then maybe I can get in here and copy.
Look at you go.
And then
we'll go for them. There you go. Excellent. There it is, everybody. It's sitting right there. Lots of thank yous, Dwayne, and lots of people now going to be able to answer that freezing rain, sleet, snow question, including myself. So everybody,
tell your friends and neighbors.
Right. Everybody's saying that it was good, informative, and interesting, and we appreciate your time. And yeah, on that note, I think we're good.
Okay. And especially if you do the evaluation, if there are other weather/climate topics you want to hear about, let us know.
We'd love to hear it. All right. Everyone take care, and we'll see you hopefully next month.
Thank you all, and thank you, Peggy.
Yes, take care.
Thank you for tuning into CUI's TV. We hope you enjoyed the show. This video can be accessed anytime on youtube.com. In the YouTube search bar, type in UPTV6 and look for their microphone logo. We hope you will join us again next week for more local, engaging content designed specifically for Champaign County older adults. Take care and stay safe.